Okay, so this video is going to explain how recombinants form and how you can recognize them and kind of the process of crossing over. So we're going to take the classic example of our fruit flies. Okay, we're looking at two traits, long wings and red or white eyes. Sorry, long wings, short wings, red eyes, white eyes. Okay, these genes are linked. Okay. So what that means is they're found on the same chromosome. Okay, so we're going to take mom here, take dad here, and they're both double heterozygous, right? So they have that and they have that. Okay, now because they're linked, they are on the same chromosome, and this is what this represents, right? This represents the arms, the sister chromatids here, and these represent the locations on the genes. Okay, so with this idea, two things can happen. We can have crossing over. Now remember, this is only going to happen on some of the gametes, not all of them, just some. Okay, or we could have no crossing over. Now, this is going to be about 90% of the time, no crossing over. This is going to be about 10% of the time crossing over might occur. And there's a whole bunch of other factors, but we're going to leave with that. So if there's no crossing over, remember, during meiosis, when these form gametes, these two sister chromatids are going to separate. So our possible gametes here and here for, I think we called this mom. This was mom here, and this is dad, okay? So mom here forms those two possible gametes, and dad forms these two, okay? Now remember, we get two copies of each chromosome, one from our dad, one from our mom. So in order to have this combination, it has to be, we're going to call it like that for now. Okay. So these are what we call the parental gametes. Okay. Because if you look at these, they look exactly like the parents. Okay. So they're parental gametes. Now, if that happens, again, no crossing over, we get this arrangement, right? Long wings, red eyes. We get three of those and one short wing one. And more specifically, you get this is a 1 to 2 to 1 ratio. Okay? So that's kind of expected, right? So if we get that, we can say, oh, no crossing over occurred on these linked genes. Now, the trickier part, and again, how we can do that is one, it's a fairly normal distribution here. Okay, so it's what we expect. And we've created the gametes here, here, and they all look just like the parents. Okay, so we know crossing over didn't occur. Now, crossing over will occur on some of these about 10% of the time. So what actually happens here is this is where, in my particular example, crossing over occurred. Okay, so the big R and the little r switched places. So what we end up with is parental combinations here. Okay, and again, those look like the parental, so that's why I circled them in blue. And we get our recombinants. So big L, little r, little l, big R. Okay? And remember, these separate through meiosis. So these, if you look, big L, little r, that combination doesn't exist here, doesn't exist there, doesn't exist there, it doesn't exist there. They're the recombinants. Right? Same with little l, big R. This is big L, so it doesn't exist there. This is little l, but this isn't big R, doesn't exist. This isn't a combination, nor is this. Okay? So we can identify the recombinants that way. Okay? Now, if we go through the whole rigmarole of producing them and things, we might get something that looks like this. We might get, say, 12 of those, 13 of those, and we get, say, 2 of those and 4 of those, for example, right? Now, that's your key to crossing over. The big numbers, and notice, are parental combinations, right? Go back up here, big L, big R, yep, right there. Little L, little R, yep, right there. And little L, little R, little L, little R, yep, right there and there. Okay, so one is the bigger number, and second, these look like the parents. Okay, now these other two, the giveaway is they're smaller numbers there. Okay, and they're similar to each other. Okay, if they're the smaller numbers, we know that those are the recombinants. Okay, second way we know, this combination, none of these combinations were in the original parental possibilities. So what that means is crossing over had to occur here. Okay, so that's the key thing. Here, you look at the numbers and you look at the combinations and you look for combinations here that simply can't exist. Okay, and again, crossing over is only relevant for linked genes. Okay, so I hope that helps explain that. Please let me know if you have any questions.